Hi, everyone. Welcome to the latest installment of our ongoing editorial webinar series, Coffee Talk. Each hour-long information-packed episode features observations and insights of an independent expert on a wide range of tech industry topics. Many thanks to the underwriting sponsor of this episode, Mission Cloud, provider of a first-of-its-kind cloud services platform tailor-built for Amazon Web Services. Without their support, this series would not be possible. And thanks to you for joining us. I'm John K. Waters, Editor-in-Chief in the Converge 360 Group of 1105 Media, and I'll be your moderator. Today's topic is AWS Cloud Costs, Top Do's, Don'ts, and Gotchas. And our main presenter is Joey D'Antoni, Principal Consultant at Denny Cherry and Associates. But before we get started, just a bit of housekeeping. This episode is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way in the next few days. We'll make some time during the talk for some questions. Please feel free to type your questions into the Q&A box at any time. On the left-hand side of your screen, you might notice some extra resources provided by our sponsor. Be sure to check those out. And as a small thank you for the first 200 attendees who stick with us to the end, we will be sending you a $5 gift certificate to Starbucks. It's a cup of joe to go with the info. Now let's meet our first presenter. With more than 2 decades of experience in Fortune 500 companies, Joey D'Antoni is a well-known thought leader in cross-platform IT. He's both a VMware vExpert and a Microsoft Data Platform MVP. He worked extensively on database platforms and cloud technologies, and he has a high level of expertise in performing, tuning, infrastructure, and disaster recovery. You guys are in for an awesome session. Take it away, Joey.
Thanks, John, and hi, everyone, and welcome to AWS Cloud Cost, Do's and Don'ts and Gotchas. I love helping organizations with cloud costs because one of the things, and we'll talk about this in a bit, is that your cloud costs typically represent your architecture. So when I help an organization streamline their costs, I'm also typically helping them, build more efficient architectures and helping them deliver better performance and give their customers better experiences. The cloud's complicated, and we see a number of scenarios that we're going to talk through today. But some common ones are where organizations just simply migrate to the cloud in a lift and shift fashion, where they just move all their existing on-prem stuff to the cloud without changing anything. And that is one of the ways we see a lot of cloud expense. There are some other patterns that we're going to talk about. There's also some low-hanging fruit around how you can save money, and we'll get into all of that in this session. Like John mentioned, I'm Principal Consultant at Denny Cherry and Associates Consulting. We do cloud and data stuff, also all clouds, all data. We have fun. We do cool things. But let's talk about the cloud. So this is a really interesting story that happened right around the time that came out a week or two ago, right around the time I was building the slides for this presentation. And this is about a team at Amazon for Prime Video that re-architected their own service, and they reduced cost from up to 90% by going from a microservices model to a monolith model. And what do we mean by a microservices model? So the team used a lot of serverless components, so AWS Lambda functions, which was a good choice because it helped them build their service quickly. And they built each of their components on various serverless and platform as a service offerings. However, as their service scaled over time, they saw their costs kind of grow and get very large because the overall cost of all the building blocks was too high as they reached scale. They also hit a harder scaling limit, so they couldn't necessarily scale each component independently. It was more like interdependently, which was a little bit of a problem for them. So how did they reduce their cost? They went to a handful of really large VMs, which is, if you talk to anyone, and the next slide is going to be about architecture, and I know I've said in the past that it's always better to have a bunch of small things than a single big thing. Well, in this case, for them, it was more cost effective to go to a single big thing. That doesn't always work, but it just goes to show you need to look at your cost and understand each component of your architecture And specifically, you really need to understand bottlenecks and where those bottlenecks take place. And if the bottleneck is a cost factor, right? So like if your most expensive component is your bottleneck. So for example, I do a lot of work with database servers, and database servers are frequently a bottleneck for a lot of organizations. If that database server is your bottleneck and it happens to be really expensive, it may be more cost effective to do a different approach. My June Redmond column that I'm currently kind of working on, I have a column on SQL Server and data and cloud in general over there, is talking about platform as a service database offerings, specifically Amazon RDS and Azure SQL Managed Instance, because I think those services, even though organizations get some benefits by going to them, they get the benefits of patching, high availability, and backups. Those come at a really high cost for those organizations, and those services tend to be more constrained than if the organizations just choose VMs. So I'm not saying VMs are better, but if you have a very high workload and you have a DBA team or database reliability engineering team that can work to maintain those things, it may be both more cost effective, and I hate to use the word performant, but I'll use the word performant, to use a VM-based solution rather than buying a PaaS solution. We're just running into something with a customer who's using RDS where there's some pretty deep internal stuff they would like to be able to do, and because it's a platform as a service offering, they don't have any controls over those specific knobs. So one of the things you always need to remember in the cloud, everything's a trade-off, and those decisions can be hard. And one of the other things that's cool about the cloud, and I'll get to the next slide and advance it because it's a apt picture for what we're going to discuss, is that it's never too late to change your architecture. In the physical world, if you built this horrible, I think this is a house or a bridge or something, it came up in an image search I did for bad architecture. If you build this in the real world, if you want to rebuild this, you need to completely tear it down first. Even in a physical data center, if you want to rebuild your architecture, you probably need to procure additional servers, maybe additional storage. In the cloud, all that stuff handles kind of dynamically. So we can build those resources kind of side by side along your current resources, and then figure out how to do a cutover. But back to the title of this slide, your AWS bill accurately describes your architecture. So one of the things I can tell by looking at a customer's invoice is how they built their solution. Do I see a lot of VM charges? Do I see heavy storage for EBS volume charges? Do I see those big RDS charges? I can also see things like licensing costs for different components that may be third party. Those are all things to keep in mind when you're building things. And the other thing too, and we're going to talk heavily about it because it's such a big topic with AWS, is network egress. So network egress is whether it's between availability zones, between regions, or even from a region to on-prem. There are some approaches you can take to kind of tackle that, but it's still always a little bit of a challenge, particularly with AWS. Probably it doesn't come up as much on other clouds, but it is something to keep in mind. So just always remember, you'd be surprised what an architect can tell from just looking at your bill. One of the things that I always like to talk about, because there are services that have very obtuse pricing models, and we have this ongoing joke about a couple of services that shall remain nameless, that we joke with our customers. They cost somewhere between $0 and all of your money a month. And these are commonly platform as a service offerings that have some kind of auto scale. So one of the ways when we're designing solutions and building out infrastructure for applications, and we want to estimate the cost, what we do is consider workloads for their peak throughput, because we don't really care about average utilization. We care about peak utilization. What that looks like at peak. And The client we were working with this week on RDS had some real struggles under peak load, and to increase that is going to be very expensive because they're already at a pretty high tier. In some cases, where you can benefit with this is using platform as a service and serverless technologies that do auto scale. Those will more right-size your design to your workload. However, it is important to kind of understand the cost, because sometimes even over allocating a fixed cost model solution will be cheaper for you than having a serverless offering that auto scales, because a lot of times those auto scale offerings are cheaper by just by the minute than a dedicated offering or a variable offering is. So that's an important thing to understand. You also want to understand if there's bounding. So if your costs are completely unconstrained. So for example, if you had a web server that was auto scaling and you were selling tickets to a Taylor Swift concert, that auto scale could be very large. So typically you're going to want to start with a fixed minimum level of performance and then use architectural patterns. Like a common pattern that we use is queue-based load leveling to do kind of asynchronous processing for auto scaling of services. This helps try to smooth out those peaks and can balance your burst performance with your cost. So you're always kind of balancing scalability and cost and performance. And your model is always going to be a trade-off between scalability and predictability. Ideally, in your architecture, you're going to blend these two aspects. This is a very general thing, and I realize what I'm saying doesn't necessarily apply to all types of systems or all types of components in systems. Given my database background, I know how challenging it is to scale a database workload without taking downtime. There are some services that do it. Those services are typically very expensive, so it's a complicated decision. But where you can take advantage of these kinds of things, it can really help you. So there are some low-hanging fruit that you can quickly eliminate in your environment. So the common one is detached EBS volumes. So these are storage volumes that were attached to VMs. The VMs maybe got deleted, or the EC2 instances got deleted or were terminated, but the EBS volume stayed in place. That's a easy low-hanging fruit. You probably don't need those disks. And even if you do need those disks, you might be able to downscale them to something where they're more cost effective. Snapshots that are unneeded. It's very common before you do a software deployment or something like that you may want to take a snapshot of a volume. Those snapshots are frequently forgotten about, which is worse if they're connected to a live disk. They'll grow over time. So you want to keep an eye for snapshots, and you can build code to just kind of look for those things and check them out. You want to evaluate pausing resources that can be paused. So one of the things that the cloud was supposed to bring us was all these wonderful cost savings by only paying for servers when we needed them in production environments. That doesn't make sense. But necessarily, but in a lot of development environments, you can pause EC2 work and just start them as needed. And then finally, remove idle network resources. It's common that you may have some load balancers or things that are hanging around. Clear that stuff up, both from a security perspective and a cost perspective. That's important. This is kind of a approach I take with my customers. This slide I actually borrowed from a deck I wrote for a large customer, where we were trying to help them reduce their cloud bills. And we kind of start out by saying, let's keep within the cost constraints. So let's develop a budget. And that's something, and I know that sounds trivial, but a lot of organizations don't develop budgets, or they don't develop software service level agreements. So they might not necessarily, like a common question we'll ask is, what level of availability do you need for this application? And it's very uncommon that we actually get a clear answer on that the first time we ask the question. And that's a major input in how we design a cloud infrastructure for an application. But you want to set a budget because then your architects can design appropriately. So before you choose an architectural pattern or a service or even a price model, you want to consider the budget constraints that the company set up. If you've ever taken an accounting class, that can be handy. But as part of the design, you want to identify acceptable boundaries on scale, redundancy, and performance against cost. And that's where that SLA comes in, and that will help you determine your recovery point objective and your recovery time objective to help you determine how available you need your app to be. One of the key cost drivers, like we mentioned, is those unrestricted resources, so things that have variable cost based on usage. But generally speaking, when you estimate the initial cost, you can set cost alerts at different scopes to measure the cost of the application, and you can pay attention to it. But it is something you can monitor easily. You also want to aim for scalable cost. You want your cost to scale linearly with your workload growth. This is really how you selected things. So where you're choosing services that scale up, in a hockey stick type curve as opposed to a nice solid 45-degree angle. So your cost should scale linearly with your demand and as you increase the scale. And if you're not in that situation, you want to think about that. This is something kind of early on you want to think about. So a good question to ask when you're designing an application infrastructure is, what happens if we get double the usage? What happens if we get triple the usage? What happens if we get 10x the usage? You don't necessarily have to build that stuff, but you want to know what happens. You also want to pay for only consumption, and this is one of the cloud benefits. So you're adopting a leasing model in the cost of hardware, development, operations, security, and data center are included in the pricing model. And you want to align this to what you're doing. And this also is going to play into reservations and savings plans, which we're going to talk about in a bit. You also want to choose the right resources and the right size. And I haven't seen this too much in the cloud, and I think maybe because everybody learned their lesson when we virtualized everything like 15 years ago. But when we started virtualizing servers, I remember talking with a VMware admin, and he was like, "Oh, your database was running on a physical server that had 8 cores and 64 gigs. So I gave you 2 cores and 16 gig. You should be fine." Editor's note, we weren't fine. Those building blocks you need to be the right size. Like yesterday, we were dealing with that customer I was talking about on RDS, and they need a larger instance, and it's going to cost a lot of money. But without major engineering work, they're not going to have any way around doing that, so they need to spend the money. And then finally, you want to monitor and optimize your cost. So even though you're going to do an initial budget for your application, you want to treat cost monitoring and optimization as a process. Conduct regular cost reviews. You want to measure and forecast the capacity needs so you can provision resources to scale with demand, and take advantage of recommendations to reduce cost. Data transfer costs, the crux of everyone in AWS. These are the 2 costs that Amazon defines. Inbound data transfer is nearly always free in every cloud. This is the case for almost every cloud provider. I haven't seen a single cloud provider that says, "Oh, hey, by the way, you have to pay to put data in." It's a little bit of the drug dealer model, as we like to call it. But if you're using S3, if you're putting stuff in the EC2 instances with EBS volumes, that data in is free. They want you to migrate there. Data transfer out is not. They typically it's all metered. So whether it's data going from S3 to your client's web browser, if it's data going from an RDS database to a report in a user in your office or at home, even if it's data going from one availability zone to another, that data is all metered. And let's talk about how that's priced and how that can impact your AWS bill. These costs differ based on whether your data is going outside AWS to the internet or staying inside an AWS region. The data transfer costs are different depending on the region, so it's important to note what region you're in. And each region has a data transfer fee for in and outbound transfers. And data transfers between multiple regions will cost more than data within one region. So keep that in mind as you're designing your application. And data transfers from one availability zone to another are more expensive than data transfers within a single AZ. One thing I want to caveat around this data transfer pricing, it sucks. Like, there's no two ways about it. It's kind of ridiculous how much Amazon charges for data transfer. Don't let this prevent you from building robust apps that can survive the failure of either a region or a single data center. What you want to do is take advantage of architectural options like compressing data wherever you can. So leads to my next slide. Any place where you can compress a data transfer, I know, like, for example, in SQL Server, if I'm sending data between servers in the availability group, there's an option for me to be able to compress that data. There are other types of network appliances where you can compress data that goes across. It's almost always worth it to compress the data and take the CPU hit, even if you have to buy a little more compute. That's another important aspect of this. So compress network streams anywhere you can. Consider using a content delivery network like AWS Cloudflare, which will reduce the amount of data that's served to the internet. AWS CloudFront, sorry, I think that's a typo. And you cache your data. Cloudflare is its own CDN, so sorry about that. My apologies. But CloudFront reduces the data that your users are going to download. So you're downloading data from AWS into Cloudflare. Also choose your regions carefully. Pay attention to the data transfer rates with those regions. Typically, you're going to want to choose the region that's closest to you or your customers. Help understand the way that data gets transferred and reduce that. And then finally, with AWS Direct Connect, which is a direct connection from your on-premises environment, the cost of network access for local to Amazon services like S3 or EC2 is lower, and you can potentially avoid the public internet. This isn't going to work for all of your traffic, but any data that's sent through that AWS Direct Connect is going to be charged at a lower rate and not the internet data transfer fee. Reservations. It's funny because I'm sitting in a hotel room right now, so I do have reservations. All of the cloud providers kind of have similar concepts here. There are a couple of different nuances between each of the vendors, though. AWS has this concept called reserved instances. It's a discount pricing model that allows your organization to save up to 75% compared to on-demand pricing, and you can purchase them in a term of 1 or 3 years. And what you effectively do is book a certain amount of computing power in advance, and you have 3 payment options. You can pay it all up front, you can partially pay it up front, or you can pay it month by month. This is designed to make your finance people happy, because whether or not they want operating expenses or capital expenses, they can take either of those expense types based on that model. Reserved instances are applied to on-demand to EC2 or other instances running in your AWS accounts. You do have to have the matching CPU family and size, so it's based on instance type. It's also based on the region, so regions are tied to reservations. Single or shared tenancy is also something that is applied, and then finally, whether it's Windows or Linux. For the discount rate to apply, all on-demand, all instances have those matching attributes of instance type, region, tenancy, and platform to whatever you have reserved. So reservations, you can't cancel a reserved instance. The commit is either 1 to 3 years. There are 2 types of reserved instances, standard and convertible. Convertible instances are useful when you're purchasing reserved instances in the payer account instead of a sub account, because you can modify them to meet changing needs, or if your workloads are able to or likely to change, so you can change against VM families and such. You also want to hedge against possible future price drops. However, one of the benefits of standard reserved instances, they allow for resale. So you can resale those reservations in the marketplace, which gives you an additional option in the event that your needs change or your budget change over time. So which kind of ironic is both cloud providers, Amazon and Azure, are both kind of trying to push more of a savings plan model over reservations. Savings plan are a little bit more flexible than reservations. Savings plans in Amazon also apply to more services. So it applies to EC2, Fargate, Lambda, or SageMaker. And what you're committing to is a consistent amount of usage, which is measured in dollars per hour, likewise over a 1 or 3-year term. So you select the spending amount of your choice. The compute usage is up to that commitment is available at that discounted rate. You get more flexibility in terms of region, location, instance type, and OS version. But it is a bigger commitment. That's what you're going to have to do. So you have that hourly commitment and you do have to spend it. So in some cases, this does force people into overuse, but especially in larger organizations, we see more and more use of savings plan. So just to tie this back to our cost management principles and how I like to view things, planning never happens enough. You can never plan too much because it's complicated and it takes time. And more importantly, in all of my long experience in IT organizations, you never have the requirement. You never have the requirements up front that you need to plan effectively. But sometimes you can. Visibility to me is a key thing. One of the things I always like to tell organizations is everybody should have access to the cloud bill, even if it's just read access, so they have a good idea of what it looks like. You also want to make your teams accountable. So having scoreboards and things like that can be beneficial. Tying it to people's bonuses is also good. You don't want to totally make it give us the lowest cost, but if you can have some iteration of cost, performance, and availability is a good way to go. And then finally, iteration. So this is always a cloud process. It's evolving. Things are going to change over time. We know that what we build first isn't going to be the end state of our system. It's easy to change things in the cloud, even pretty complicated things, especially compared to on-prem. So keep all of that in mind as you're looking at solutions to build out and architectures to build out in your cloud environment. I think visibility is kind of the most important thing to me. So keep those things in mind. Finally, and this kind of ties into my visibility and accountability point, resource tagging is the way we just tag things. So we know within an account what types of things. And there are all sorts of tags you can use: data classification, criticality, SLA, environment. For the purposes of what we're talking about here, cost center is a really good one to look at, so you can know whose resources are responsible for what. Tagging has all sorts of numerous benefits, not limited to, but including automation and cost at the end of the month. And this is also something else that I don't think a lot of people do enough, but it is something that I think can be really beneficial and help you better understand where your costs are and try to more quickly identify those outliers. So with that, that's kind of our coffee talk for today. Before we hand off to Mission Cloud, John, do we have any questions?
We do indeed. Thank you so much. That was awesome. I want to remind everybody that you can type your questions into the Q&A box at any time. We'll get to them as best we can. So I want to start here with Lynn Ma, who's a frequent attendee. And the question is about how to handle resource provisioning. Over-provisioning resources, such as using large instance types or allocating more storage than needed, can significantly impact costs. So the question is about how to address that.
For sure. I was watching a Silicon Valley rerun the other day, and it was with Jack and the conjoined triangles of success. And I feel like this with my comments about visibility and accountability. That really and planning, right? So this ties into planning. And this happens, right? You plan for way more utilization than you think you're going to have. That's fine. I don't really care. But unless we're on the edge, I don't really care if we spend way too much money 1 month. But that visibility and that accountability is going to allow you to potentially downscale things the next month. And there are certain types of workloads that can be very tricky to downscale. Like if you've allocated a bunch of data that's in EBS volumes in a VM that's like over provisioned, you may actually have to do a real migration to get that out. But if you've over provisioned it that badly, the cost savings may be worth it.
Okay, we've got another question here from Wahid, who I think is another frequent flyer. Are you familiar with NetApp Spot? If so, any thoughts?
I have not used that service. I've looked at some other services, and just to put in a plug for our sponsor today, I think pay attention to what Mission Cloud has to talk about. I think they have some kind of neat stuff.
Mm-hmm. Absolutely. Okay, here's one from Zeke, who's wondering, Joey, how do you decide between cost savings, plans, and reservations?
Cost savings, plans, and reservations, it's really going to depend on the nature of your spend and kind of the scale and size of your company. Cost savings plans typically imply that you're spending a lot already and you just want it to be flexible and you're committed to that spend. I almost think about it like enterprise agreements with, I don't necessarily say legacy vendors, but enterprise agreements are definitely a thing that's kind of fading out in terms of popularity, but it's more like an EA, whereas reservations can be, cost savings plans aren't going to be beneficial until you reach a certain amount of spend where you can reliably predict your spend. You can have 2 or 3 VMs that are supporting a single application and get tremendous benefits from reservations because the cost savings are that dramatic. I think that's one of the most important things to understand around that. So probably your entree into this is going to be reservations. But as you grow your spend and grow your utilization, you may end up in a situation where you're using savings plans.
Okay, we've got a question here from Tron, who's wondering what tips do you have for saving specifically on storage, i.e. S3?
Specific to S3, automated lifecycle management. Amazon provides tiers for that storage. You can have it age based on utilization, so that you don't have to automatically handle that, and you can even have that data just fall out of S3 over time if that is within your lifecycle policy. The other thing to watch too with S3 is utilization cost, and if you're having, for example, website assets. It's another place where caching can be beneficial in terms of not having to serve that. Because remember, S3 has 2 price dimensions. It's the volume plus the utilization. So if you're constantly reading a file directly from S3, you're going to have that dimension really hurt you. So keep that in mind and take advantage of things like CDNs where you can.
Okay, Edwin is wondering, how can you manage data inaccuracies?
That's an open-ended question. I'm guessing Edwin's specifically talking to billing, which we had an interesting with one of our cloud vendors that we work with, where we got they kind of randomly, they didn't double bill everybody, but everybody's utilization went up 18% 1 month, and we had to figure out why. It turned out it was a billing error. I mean, if you can clearly identify your billing, and so this is one of those places. Billing errors do happen. They're not super common. AWS is pretty good at getting you your bill accurately. But if you have that good accounting and that good reporting and you know what your bill is supposed to be, you can quickly identify it and work with them in order to in order to quickly be able to mitigate that and try to get some response from them on that. Like I say, those errors are kind of uncommon, but at the same time, it's important to keep track of that stuff, because if you don't have clear visibility into it, you're not going to be able to quickly react.
Mm-hmm. So lots of questions on costs today. Joey, what are some common sources of runaway costs in AWS accounts?
They are kind of numerous. The common ones, though, are one of the common ones are just network related. So gateways can be especially if you have a lot of data flowing through a gateway. That can be a big surprise if you have data going from region to region, or from the cloud to on-prem. We had a customer where they had a really large database, and the way we discovered that somebody was like downloading the largest table in the database into Excel every day was through their cloud bill. So typically you're going to know what your big expenses are, but when you see, like, when you have a really big VM and you see some network cost that's like twice as much as the VM, it's always a bit scary.
Mm-hmm. Fascinating. So Anne here is wondering, is Direct Connect worth it?
I think if you're going to be consistently moving data back and forth between an on-premises data center or even an on-premises office and AWS, it's worth it. Your costs are going to be reduced in terms of just your raw egress, and your users are going to have a better experience because they're going to have lower latency. And you can really design some apps to work in a true hybrid fashion so that you can easily move data back and forth between the cloud and on-prem. So I think it's something that almost all of our enterprise customers go for, less so for startups. If you're 100% in the cloud, it's probably not worth it. But if you're a well-established customer and you have a real office or data center presence, it makes a lot of sense to pay for Direct Connect.
Thank you so much, Joey. That's all the time we have for this portion of the Coffee Talk. Much appreciated, man.
Thanks, Sean. I appreciate it.